Hi, Phil here again, and today I'm going to talk to you about technology in the senior school. First of all, we've got to understand when we talk about technology, we've got to think that technology is not just about computers and graphics calculators. We can still understand that the technology is old school, pen and paper, scientific calculator, all the way through to iPads, computers and the like. We talk about a continuum of using the technology. And the hierarchy, as we talked about in one of the earlier videos, is that talking about pen and paper at the lowest end, all the way through to saying using a laptop computer or a computer at the highest end. Your school will make a decision about bring your own devices, whether they supply students with graphics calculators or do students expected to buy them. But it is expected that students, whether they own the device or not, should have access to the high-end graphics calculators or computers. Well, what's the purpose? Why use graphics calculators or computers? And there's varying reasons why you do that. It's not just to use it as a big number cruncher or a graphics display. There's many reasons why we might use those things, and I've put some of those things up on the screen there for you to see. In the end, what we want to do is the students to develop thinking strategies, and if we can use the technology to support that, then that would be great. Of course, with all of this technology, there's a payoff. If we use the graphics calculator too much or the computer too much, we also have to maybe have a payoff in that there's less use of algebraic techniques or graphing techniques for the students to develop. So we've got to understand there's still got to be that balance between how much we ask the students to use pen and paper and how much we use them to use the graphics calculator. So that dynamic there of which do we use when might be something you want to think about. Here's something that I use a graphics calculator otherwise to think about. Well, the question's about what happens if, asking the students to develop in their own way some modelling or whatever. So what happens if we graph an A sine B, y equals A sine bx, and what happens as b increases? So we're getting the kids to play. In my day, we would have drawn y equals sine x, y equals sine 2x using pen and paper. Took us a whole hour lesson to do that, and then we're asked to generate some sort of model in our mind of what happens as b changes. So we're going to use the graphics calculator there to do that really speedy number crunching and graphing crunching, and so we can get the students to construct the knowledge of what's happening that we want to develop. Little investigation, for example. We know the Fibonacci sequence. It's not particularly in the program quite so much, but we can certainly use it when we're looking at sequences. What happens as the number of terms increases? Can we say that that the Fibonacci sequence is almost an exponential model, and we can use a graphics calculator to create the sequence? What's the ratio between any term and the term before it or after it? And then we might say that yes, that's developing a sequence that's an exponential one or whatever. But we're using the calculator there to think about why would we be using it for this particular task. When you're planning these things, you might want to plan them really well ahead, because discuss them with your colleagues. It's time to really think about what we can use them for. I'd really feel really bad if the kids in my class were only using it as a calculator, or in the computing sense, maybe it was a typing thing, a typing device. But think about, what do I want the students to actually develop? And I recall a little bit earlier with my students, and I asked them I thought it was a really funky limits question, where we've got a function that's undefined for the value for x that we're trying to find the limit of. And so they're going to have to do some factorising, blah, 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 blah. I thought this is a really good question. And a student wrote down, the T Inspire says that the answer is 2. Not quite what I expected. And so maybe some thinking about, well, if I'm going to ask this question this particular way, what am I going to use the technology for here? Am I looking for old school technology with pen and paper, factorising, etc., etc.? So just something to think about. In summary then, what I really sort of want you to understand, that we want to use these devices to support student learning. We want them to be able to construct knowledge, and how do we use these devices to do that? Okay, so thanks for listening. Have a good day.